All right, ladies and gentlemen, hello and welcome back once again to the only coast to coast radio show all about the information economy. It's called Inside Analysis. Yours truly, Eric Kavanaugh, is here. And folks, we have a fantastic topic lined up for you today. A good friend of mine, Ellen Rubin, with a company called Causely, is on the show. She's been in the business for a while. She was at Netezza, for those of you who remember Netezza, which took the market by storm years ago, a data warehousing appliance. And of course, it got bought by IBM for like $1.2 billion or something amazing like that. And I was like, wow, how did that happen? I asked my partner, Dr. Robin Bloor, I said, why would IBM go and buy Netezza? They have their own DB2. And he said, well, when you can borrow money at 0%, why not? And I was like,
That sounds like Robin.
that's a good
Yeah.
point. That's a good point. So anyway, yes, Ellen Rubin, welcome to the show. Thank you for your time today.
Thank
And
you. Pleasure to be
so
here
you're
and
with
nice to
Causley.
remember old times from that time. But a lot of technology has happened since then for sure.
Yes, that's exactly right. I gave a presentation. In fact, I moderated a panel in New York last week, Forever in Your Technical Debt, which was all about that, like dealing with technical debt. And it's out there and it's everywhere. I mean, one of the funnier quotes I've heard over the years was someone who defined a legacy system as any system in production. It's like, all right, I get that,
True.
right?
Yeah, true.
But you folks, we'll talk today on the show about causal AI and what causal AI is. So, Alan, I'll give my take on things and just kind of see where you fit in this whole conversation. But when I look at observability, which is now everywhere, I mean, observability, I think it skyrocketed faster than big data, which went really fast. And of course, LLMs now have skyrocketed faster than anything. But observability 3 years ago, I don't even know if it was a term, and now there are like 50 observability vendors. And I think part of the reason for that is because of Kubernetes out of Google, because this new distributed way of container orchestration is so different and so dynamic that all of a sudden we have all these new sources of information that we can pull together, which is great for developers and site reliability engineers and the application teams, the people who actually build the apps and maintain the apps that run business these days. It's good for them, but also it's a blessing and a curse because suddenly we have 5, 10, 20 different sources of data, and it's up to the individual to parse all that stuff and to kind of pull it together. And I've noticed this for, gosh, in the first year of DM Radio, I interviewed a guy from a company called Precisely, Zohar Gilad. I'll never forget his name, Zohar. And Precisely, or I'm sorry, it was called Precise, and it was basically troubleshooting. And so you would look at CPU usage and network behavior and app performance and all these different things, and you get histograms. But the point is, the developer had to piece this all together in their head, which is hard to do. It requires a lot of experience, a lot of hard knowledge about how things work and how things interrelate. And of course, these days, companies create run books and all kinds of different things to help the SREs and the others figure out, okay, if this goes down and that happens and this happens, then do X. And that's good for as far as it goes, but wouldn't it be nice if something came along to dynamically absorb these different data feeds, correlate them, and that's the key. When this goes up, that goes down, which means one thing. When that goes down, this goes up, that means something else. To be able to correlate that and understand that and parse it, that's getting pretty powerful. It's my understanding that's what causal AI is, it is, at least in this context. Is that right?
Right. So, kind of taking the step back that you started with around what's going on and why are the problems in the industry getting so much worse than they used to be. Obviously
Right.
monitoring, APM, ability to measure and have metrics on what's going on. These are not new concepts. And anyone who's been in the IT operational space for a long time and has had to run and scale and own large applications and infrastructure, like these are a lot of these problems are old problems. Like stuff breaks, things slow down, things go wrong. You don't understand what happened. So that's many decades of problems. But the point that you made, which I think is right, is that in some ways things have accelerated in the past 10 years, not only with the adoption of microservices and Kubernetes as a good example of that, but also just the sheer pace of people using DevOps and being so agile and rolling things out all the time, that you really have a lot of room for confusion and room for complexity that is in some ways exponential compared to what used to be the case. Certainly when you had more of a monolithic environment and people had more of a somewhat less dynamic set of changes that happened, in a less, agile kind of a rollout approach, you could kind of know more about what was there or what was in the stack and what changes were being made. And now, there's so much more frequency of changes, and there are so many things that can happen dynamically where people are using your application and their load patterns are changing, or the way in which the application gets rolled out and scaled out can be constantly causing new problems that you're not aware of. And no one person has a view of what's actually going on. Not to mention that there are all these interdependencies between services in that type of an environment, and between the infrastructure and the application layer of things that, frankly, a lot of people have no clue what's going on at the infrastructure layer anymore, right? Like, it used to be
Right.
a little bit easier to get to the bottom of what was going on there. Now it's all the interrelationships and the interdependencies. So if you look at that kind of a world, what you can see is that observability, like Datadog is a great example, took off with the rise of cloud and this type of kind of shift into a much more agile world. And that has driven tremendous growth. And then, of course, there are a lot of companies that are sort of the next generation of observability. But a lot of them, and I would make the case that kind of like the whole industry is still focused on saying, well, if we just monitor everything, if we
Right.
just have a metric on everything, every piece of everything, and now there's so many more everythings that now we need to store all of that data, and we need to hold on to it for longer term trending and compliance and all that kind of stuff. And so what they've created is a little bit of a like a the gift that keeps on giving, right? Like, the more things that you're looking at and tracking and measuring, the more room there
Right.
is for people to say, well, something looks wrong here. What's actually going wrong? Oh, now we've actually had something more service impacting. Now what do we do? And
Right.
often the interdependencies of those things are not clear. And also the people who are involved might actually sit in multiple organizational teams or functions and try to pull it all together. And the poor, SRE or incident response person who gets hit with this is like, okay, where do I start?
Right.
And in particular, if they don't have a lot of knowledge and expertise of the particular area where the problem is. So these are all things that we see all the time. And so I think your initial point is the right one, which is, to some extent, the more observability tries to solve the problem in the industry, in some ways, the more problems get created, because how many hundreds of alerts can you look at,
Right.
right?
That's
People
right.
simply can't keep track of it and they don't understand it. And sometimes the alerts that you're getting are the symptoms and not the actual cause. So that's
That's a
that's the problem space that we're coming into as Cogsley, and bringing a lot of knowledge and expertise from the founding team from this particular set of problems.
Well, I mean, you hit the nail on the head right there with the fact that many times what you see are symptoms. That's not the problem. And root cause analysis has always been difficult. It's always hard. But I will say that the power of machine learning is very compelling here, because machines can scan vast amounts of information, log files, for example, usage patterns. And the key, obviously, is to capture that and to identify the correlation, help the end user find the causation or even find it for them, and then catalog that and know for next time when this set of circumstances comes, aha, it's probably that problem we had before. Maybe not. There can always be some new piece of information coming in, but to be able to dynamically ascertain the correlation between feeds and thus get you closer to the causation, that's a huge deal, because, one of my big themes here is morale and morale of your teams. And your SREs, your app teams are going to have very low morale if they can't get to the bottom of things. If stuff breaks and they can't even figure out how to turn it back on again, that is not good for the home team. That's not good
Right.
for anyone involved. And so what I love about this causal AI is that it's greasing the tracks to the correct answers, right?
Okay, so I'm going to shake your world. Forget about correlation.
Oh,
Correlation is history. The way
interesting.
people think about correlation is stuff's going wrong, and there are a whole bunch of things I got alerted on, and I'm looking at the picture that I have of my topology and the incidents that I'm seeing, that all my tools are telling me about. And I'm a human being, and I'm trying to figure out how those relate to each other. And mostly what I'm looking at is anomaly detection together with
Hmm.
correlation. That is the state of the world right now. And what we're saying at Causley, and what we as the founding team really believe in very strongly, is in the end, that comes down to providing human beings with pieces of information and updated, pictures of their environments in reality, that still they have to piece together what's going on. It's like the joke, right, about correlation is not causation. So let's just
Right.
pause on that for 1 second. Like the most the funny one that people always talk about is how like ice cream sales in the summer and
Right.
sharks correlate. Like
Right.
that's the most obvious one. So like if you think about it, you realize how ridiculous it is, which is of course those things correlate with each other. But the root cause is like that it's the summer, right? It's a season, and it's hot, and people are outside, and sharks are outside too. So like
Right.
there's something about that I think the industry has not kind of accepted or believed that it's possible to do more than that, and that as a result, capturing all of this data or having to do more of a bottoms up approach in which you try to like build models that you could automate, to your point, run books and all of that. But in the end, all of that comes down to that some human beings with some expertise and knowledge took a look at things and said, okay, that's actually really the thing. Because if you start to
Mm-hmm.
fix something and you're not fixing the root cause, all you're doing is pushing the problem around, or just it's going to come back later. So the philosophy that we have at Causely is that really what you want is you want to have the knowledge of causal relationships, of cause and effect, not correlation, but causal effects,
Mm-hmm.
captured in software and automation, as opposed to relying on human beings. And that's a really hard problem. It's not something that a lot of I think people in the operational space and in AI ops and other areas that are kind of part of the industry have really wanted to take on. And so they're focusing more on how do you automate the human capabilities that are out there and make those more repeatable. And what we're saying is let's go to the heart of this and capture the actual causal knowledge and ability to say what these causal relationships are. And we do that in a very particular way that's based on a specific approach that my co-founder and the founding team bring to the table. But really what we're trying to say here is that what you would want to see in your application environment and in the way that you build and run applications is that you are able to maintain and run these applications reliably. You're able to ship code without breaking things. You're able to have new changes that are constantly happening, customers using your application in different ways, and that all of that can be maintained in a good and healthy state where you're able to meet your business objectives, you're able to meet your service level objectives. And at the heart of that is the fact that there is this causal knowledge that's being captured. Because without that, you're playing whack-a-mole, right? You're running around your environment trying to fix things and tweak things and improve them. So that's the approach that we take to the industry, and we happen to be using an approach that is a causal AI platform that we've built, and that's technology that we are running our first product on that is available now for people to be testing with. So that's kind of the approach that we've taken, and I think that a lot of companies that are out there are hoping that they will automate things enough, with enough data that eventually they'll get a picture of reality. But of course, then things change 10 seconds later. And one customer's
Right.
environment is not like another customer's environment. So these are all things that we, from our approach, the bottoms up is not the right way. The top down is the right way to think about it. And that's
Very
part of the causal platform.
Yeah, that's very interesting. So, in other words, the technology, the AI that you're using is designed to focus on understanding root cause, which,
Yes.
as we've discussed, is very difficult typically to do. But it's not terribly difficult depending upon the algorithms that you're deploying, because you can run what if scenarios very quickly. You can do all sorts of Monte Carlo assessments essentially on the data. And I'm guessing that when you find certain things, you are cataloging that. Is that correct?
Well, we're actually using a very different approach than that. So some of the things people are familiar with using, machine learning and, more traditional types of AI approaches that are out there are approaches that other companies use. We are coming at
Mhm.
it from the perspective that you need to start with what we call structured causal models. And there,
Mm.
what we're able to do is we're able to capture the relationship between the root cause and its symptoms um, in a very generalizable and very abstracted way. And we've
Mm.
created these and we've captured them in software, and that's a key part of what we've built. And that's just out of the box. It's not like, oh, we have to come in and understand something unique about a customer's environment or what their relationships are there. But we've done it at a higher level where we're looking at problems that are things like noisy neighbor and database slowdowns and congestion across data pipelines and message broker problems, where often it's the interrelationships between a lot of the different parts of the environment and things that could be very multivariate, right, in terms of how many different things are interacting with each other in real time, make it really hard for human beings to troubleshoot. And so we've captured those in our structured causal models, and then we're applying the causal inference engine that we've built to these problems. And all of that is happening with a live and dynamic real-time customer environment, right? Where we're sitting in their environment and we're able to see a lot of the, kind of like the data sources that exist about their, what's happening in their Kubernetes cluster and in their cloud services and what's happening, across the environment with databases and networks and, and message brokers and networks and stuff like that. So we're essentially taking all of that in as live real-time feeds, and we're able to then apply that to these causal models and use the causal inference to say, hey, at this moment in this particular customer's application, this particular set of scenarios, these are the things that are problems that are either happening right now and you need to do something about them immediately, and here's how you should take action, or these are emerging problems, things that are potential things that could happen in the future that you would want to be aware of and you may want to take action on in a more preventative way. And that's the causal relationships really help us to do all of that.
That's very interesting. So you've built these models, and we'll pick this up in the second segment here in just a minute, but it sounds to me like a foundational model for causal AI, for troubleshooting and finding root cause analysis. And just to explain to our audience out there, foundational models, well, like the large language models, are, I think, going to reinvent enterprise software, but they have to be very focused. The large language models are very, very big. They have billions of parameters. They still work. One of my good friends heads up actually at Northeastern in Massachusetts, the Institute for Experiential AI. And he was joking when I talked to him on the show earlier this year. He's like, these models, they're too big. They're not supposed to work. Nobody knows why they work. I'm like, okay, you're running the whole institute. And you're telling me
sometimes
no one knows
AI does have that feeling, right? Like nobody knows
well,
why it works or it doesn't work, right?
like that's kind of scary.
Yeah.
But so we'll pick this up after the break. But it sounds to me like you have built a foundational model in this space, and it's very, very interesting stuff. Don't touch that dial, folks. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to Ellen Rubin of Causely AI, which is a company, guess what, focused on causal AI, which is really interesting stuff. So this is not large language models. This is not some of the other foundational models you've heard about. Specifically, what the folks did here is they focused on these structured causal models, and they look for very specific types of symptoms and can help you use an inference engine to know when this variable changes, that variable is going to change. So they're basically looking at the inner workings of a system to understand how it works. And that's why they can get to the root cause of some very complex problems very quickly. Is that about right, Ellen?
Yeah, that's definitely in the right direction. So, for us, the whole point of this is to remove human effort and, challenges that require sometimes days worth of like, what the heck is going on in my environment? And so there is there's no effort or lift from people who would be using Causely to have to, use our inference engine or to have to create any of the models or apply the models or whatever. That's just completely automated and completely out of the box. And that's something that we think is really critical here, which is if we're going to automate this in a way that allows us to go all the way through to what do I need to do to fix this? Or who do I need to inform about this information so that they can make a change in their code or do whatever it is that needs to get done? You need to take them all the way through, right, to the conclusion. And so it's really about understanding the root cause of what is happening in the environment, and even better, to help people see things that could be emerging problems and potential things that might be happening in the future, because it's such a dynamic environment that they're living in. So that's really important. And I think what you were saying earlier is key, which is we're really looking for the symptoms of certain types of problems that are these, often challenging, very complex problems that people deal with all the time. And by doing that, we are more efficient, and I would say almost more like laser focused on, based on seeing these particular types of symptoms, we can tell you what the root cause is, and we can show that to you automatically in a completely, real-time way. And it doesn't require you as the human being to then sift through a lot of other pieces of data and try to say, oh, okay, that looks like it. Now let's go try to fix that and see if that actually was the root cause. We're telling you
Right.
automatically. So we think that
Wow.
that is that's just the way the world needs to work in the future. And it's been very, very hard for people to do that up until now. The fact that there are LLMs and the fact that there's machine learning, we'll take advantage of all of these techniques that are out there. These are known techniques, but what we're bringing uniquely to the table is the ability and the expertise to have built a platform that is this really, really scalable, really, really, automated platform for capturing cause and effect relationships, which,
Hmm.
nobody else has done so far.
Yeah, and it gets into graphs too, right? Like directed graphs and acyclic graphs and things of this nature where X leads to Y, which leads to Z, et cetera. So you identify these patterns and then you look for when it applies in a particular scenario. Now, I'll throw out sort of a random anomaly here or analogy, I should say. What I remember from taking calculus years ago is that if you skip a day of class, first of all, you're toast. So do not skip a day of class. You have to be there every single
Okay,
day.
but you kind of knew that back then too, right?
That's right.
That you probably
But
shouldn't skip a day. Yeah.
but I remember what I remember about it that was very interesting is that there are X number of patterns, and you have to sort of you have to infer what the nature of the problem is to apply the right formula to figure out the problem. And it sounds like these structured causal models are the foundation for that. So they have a certain number of these views of the world essentially baked in from experience, and then you apply it to whatever the situation is. And then the way it works is it looks for certain characteristics, certain symptoms, as you mentioned. And when it finds that, it goes, aha, we recognize this pattern. We think this is what's going on. That's basically how it works, right?
Right. Although it's less about we think and more that we feel confident, and that, a lot of it is applying it applying this causal AI approach to the cloud native and operational world is what is unique here, right? Like the
Mm,
field of causal AI, we were chatting about this previously, like the field of causal AI is a known field. This is, people have been at this for a very, very long time. There are people who are famous in this field, like Judea Pearl and others who have worked on this, at many universities. And it's frequently applied in things like healthcare and marketing and financial markets and stuff like that, where the need to know about causality has been strong and people have applied it into those situations. But usually it's done in a very project-based type of approach. Like, here, we're going to build something
mm,
for this particular organization or this particular team that solves these particular problems. And in a lot of ways, it's kind of a closed system, right? It's meant for that
mm.
particular, it's kind of a proprietary thing that people work on within the analytics or the data teams. What we're saying is we've now created this in a really generalized way and an abstracted way that can be applied to the overall cloud native and IT operational world. And we happen to have picked a certain set of initial problems that we're focused on, and we're doing initial work with companies that are
I
using more
see.
microservices based environments, but it's more
Right.
generally applicable than that.
No, that's interesting. So you have a very focused approach, and that has allowed you to leverage these models. And let's face it, I mean, the challenge now for developer teams, for application teams, to your point earlier, is that the environment is incredibly complex and it's getting more complex by the day. And I don't think that's going to change. So what can you do differently? And that's where this approach comes in, right? Is to leverage the known science of causal AI and to map that against the symptoms and all the data that's coming from these various environments, but
That's
to
it.
keep it simple and look for the patterns, right?
Right. And to make it an out of the box experience, like, think about the people who are responsible for building and operating large scale, very, very, kind of complex application environments. Like, huge companies that have these applications, where they have like thousands of applications, is also true. And think about the nature of the job for the people who are the DevOps people, the SREs, the people who are handling incident response, the people who are on call, like all of those types of people, let alone the people who are in the mode of like, I own the KPIs and the metrics that are the business and technical metrics for how this application is behaving. Like, you don't want things to break all the time. You want to ship code faster, and you want to be able to adapt to dynamic and changing customer needs, and things that happen at peak periods, and new things that get thrown in because the cloud infrastructure underneath you keeps changing. You're living in that
Right.
world, and a lot of times what you're thinking is, oh my God, like if I just don't have every piece of information on every single thing that's in my environment, I might, something terrible might happen, right? Or I might not achieve the goals that the business needs. And from us, the philosophy is, what can we take away a lot of that confusion and difficulty and pressure? And even if you're not somebody who's been on the team for very long, or even if you only know about a few services that are the services you're responsible for, how do we give you this kind of out of the box and really fast experience that allows you to then say, okay, well, I don't have to worry about that anymore, right? Like, the environment is going to be healthy and it's going to be resilient, and we're not going to be constantly, kind of playing the whack-a-mole game. And really,
Right.
we can focus on the things we care about, which usually have to do with, I have new features to roll out. I want to make sure that I'm, kind of architecting things for a better experience for the customer or for bigger scale or whatever it is. And that's where the energy should be going.
Yeah, well, I mean, I happen to know from experience that talk about whack-a-mole, you can spend the rest of your life trying to track down problems and never even get there if you don't have the right perspective, if you don't have the right information at your fingertips. And what you're talking about is providing this sort of foundational component to solve those problems out of the box. I guess one question I have is, how do you deploy? Like, when someone actually buys the software, where do they deploy it? How do they deploy it? Is it in the instance in the cloud, or how does that work?
So the initial product, the initial Causley product, is it deploys into a Kubernetes cluster. So
Okay.
we kind of are, using that as an initial. As I mentioned, that's kind of our initial decision about, kind of starting with those types of environments. It can be used more generally than that, but for the initial product, people would deploy us, and it's like a couple of minutes, to be up and running in their Kubernetes environment. And what we are able to do, though, is we're able to see things that are, well beyond what's happening in Kubernetes. So all the different cloud services and the, all of it, and all those different interrelationships that I was describing, we're capturing those automatically and out of the box using a lot of different data sources. So, APIs from the Kubernetes and cloud environments, using accessing data from Prometheus, leveraging OpenTelemetry, eBPF, Istio, all of, a lot of
Oh,
open
yeah.
source tools, and then being able to take alerts and other information from products that a lot of the customers would be using, like Datadog and similar
Mhm.
observability products. So all of that is kind of input to us, but that just happens automatically. The customer doesn't do anything, to make that happen.
Hmm.
And then, the idea for these customers is that they would be able to immediately see, like, it's not, they don't have to run it for a while and baseline anything. Like, they can immediately out of the box start to see what's happening in their environment. Not only, of course, the topology and, what their environment looks like, but the causal relationships that are in place across that environment. And we think that that's really exciting and compelling, that when people can see that, all of a sudden they're like, oh, wow, like, we have this idea of, like a causality tree that basically shows the root cause with all of the different symptoms. And that's something that is a view within the product that we're able to say, here, look, for this particular issue that's happening, it's either an existing problem or it's a problem that could happen in the future. Here are all the causal relationships, and we can tell you a lot of the information around them, and you can dig deeper on them, with as much, more detail and metrics and data. But really, the thing that you want to see is, in my environment, this particular issue is happening or it's about to happen, and here are all the causal relationships that are captured visually. And
Mhm.
so we think that's really fun, and that people, will be excited to have that. And kind of early working with early customers, a lot of times what they say is, this is the first time we have this view of what's happening in our environment, as opposed to a more
Wow.
general topology view, which I think they're used to seeing.
Well, I mean, understanding causation across these environments, that's the key, because one problem here can propagate over here and over there, and those are the symptoms that you're seeing. But to your
That's right.
point, with this structured causal model, you're able to say with great certitude, when certain conditions are met, okay, we know what this is, right?
Mm-hmm.
It's a pattern matching scenario, but it gets you to the root cause very, very quickly. Like, okay, this is it. Now we know, basically, it's like,
Right.
it's not even probabilistic. We know that when these conditions are in place, X is happening, or we know when those conditions are the place, Y is happening, and here's what you do. And then you actually go to the next step. Is that right? Do you actually then remediate with automation to solve some of these problems?
So you're a experienced person in the industry. So the remediation conversation is always a conversation, right? So basically, we can remediate all the way and take action, right? That is definitely something that we do, and we can do it. And in some cases, customers have told us, please do, right? Like if you can actually just go ahead and kind of do
Yeah,
certain
fix it,
types of actions,
make it
please
work.
fix it. Yeah,
Right.
take it away. But often in some of the larger customers we're working with, there's a desire for it to become a part of a set of change management CI/CD pipeline that's already in place, and for obvious reasons, right? Like you can't go around those systems; you have to live within them. And so
Right.
a lot of the work that we're doing is to just make sure that we tie very seamlessly into that. Like, how do we make sure that if the way that they take care of certain types of problems is by a set of things that they've built in their infrastructure as code, well, then we should just tie into that, right? We're not going to reinvent the wheel for them on any of those
Right.
things. And
Right.
some of it, is to some of the things that you were saying a little earlier. There's like if the right person gets the information they need and they're able to have that information immediately, then sometimes the action that needs to be taken is a human action, right? It isn't really
Right.
an automated action. Like, could you re-architect this so that it doesn't have this choke point? Okay,
Right.
that may take a little bit.
That see, this is very, very interesting though, because I understand that, and I think a lot of people on the outside of enterprise applications don't fully appreciate this, and I think they will more so as time goes by. But every environment is different. Every environment is bespoke, especially when you have these hybrid cloud environments. I mean, yes, the cloud is sort of garden variety, if you will, X number of services that we can all use and cobble together. The second you touch some on-prem environment, you have a whole nother set of challenges that are very complex and that are very bespoke and that will need special attention, which is why off the shelf stuff sometimes requires you to take some extra added steps to connect it all and to get it through and to understand with the client what environment they want. What do they want to get out of this? So I love that it solves a lot of these problems in terms of getting to root cause analysis, but you have some opportunity for the client to say, well, we'll do this or do that when it comes through because they're just different environments with different responsibilities and different people, right?
Having spent my entire career working with enterprise customers, you have to meet them where they are on some level, right?
Right.
Like, so they're on
Right.
a journey, right? They're on a journey in cloud adoption. They're on a journey in Kubernetes adoption. They're using different
Right.
types of observability and they're adopting more. Like a lot of them are on a journey with open telemetry, right? And trying to figure out how to bring that in a more standard way across their environment because they know that that's a direction the industry is moving in.
Right.
All of that's happening in the background. And our job is to make sure that it doesn't really matter that where the
Right.
customer is in that journey. We're able to kind of meet them there and provide them with the things that they need. And as much as we can build things into the product, automatically, the better. And also to a certain extent, sometimes it's aspirational, right? You have these customers who are like, we really want to move in this direction, and this actually is going to help pull us forward, right? Like
Right.
the fact that we're going to be able to see all of these different service dependencies and all of these interrelationships is something that we know we want to do, and that this is like, here's a great use case for what you're going to do with having that information is you're going to be able to see more causal relationships across all of that.
Yeah,
And
that's
it's
exactly
not just
right.
data, it's useful data.
That's exactly right. Well, folks, don't touch that. Dial. We'll be right back with Ellen Rubin of Causely AI. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking all about causal AI with Causely.io and Ellen Rubin. And Ellen, we were talking about the people, right? Every company is people. A lot of people say it's the technology, it's the hardware, it's the software, all this stuff. That's true, but really a company is built around the people. And one of the coolest things I've noticed being in this industry now for, 25, almost 30 years or so, is that you can see the progression of individual professionals from one company to another. They learn things, they learn about this situation, that situation, and that becomes part of the fabric of their view of the world. And that's how you can learn how to bring things together and create whole new projects. And I think what you've done here is very interesting because you came at it from a different direction. Like a lot of this stuff is inside out almost. You refer to it as bottom up. I'm almost going to say it's more outside in because you're like, or maybe it's the inverse. I'm not sure. But the point is, you figured out a different way to address this issue, and the people are the ones who came up with that. So who got together to create this besides you?
Thanks. Yeah, and I agree with your analogy of it being, that it's outside in instead of inside out. So I like that.
There you go.
I think the people in this case, I mean, look, the founding team is always critical, and the reason founding teams start something is because they had a problem that they saw, they wanted to solve it, and they think they have something interesting to say, to bring to the table. So in my experience, having started several companies, and as you mentioned, being part of some other startups from the very beginning. This team is pretty spectacular. So we have my co-founder Shmuel Klieger, who was the founder of most recently of a company called Turbonomic that was acquired by
Oh, I
IBM.
know them.
Yeah, so they
Sure.
were, they had this fantastic, $2 billion outcome with IBM. But before that, they had taken on a lot of issues about IT operation and how you are able to automate initially in a VMware environment, and then they kind of moved out and made it a broader problem set. And so a lot of this idea of automating IT environments and making sure that they're working really well, they solved a lot of it, and it was kind of more focused at the infrastructure layer, right? That's where a lot of the work was done. Prior to that, Shmuel was the founder of a company called Smarts. I don't know if you remember that company. They were in the root cause analysis for network management, and they were acquired by EMC, and that was also a really successful outcome. So it was kind of like the people who are the founding team, there's a huge amount of DNA from Turbonomic and also from the previous company, Smarts, with this root cause analysis expertise and knowledge that was applied back in the day to, a completely different world, much more monolithic, on-prem, static, all these things that were going on. But the building blocks were the same as the things that have been brought to Causely. And then large scale, enormous IT environments, at Turbonomic that needed to be managed and run in a way that, took away a lot of the pressure from the people who were having to do these things as initially VMware and then cloud became, hugely deployed. So that's a good chunk of the team. And then for myself, you mentioned Netezza, which is, kind of back in the day in data warehousing. But I also, after that, started a couple of my own companies that were very focused on hybrid cloud and being at the cloud infrastructure layer and understanding, how do you create environments that span on-prem into the cloud or multiple clouds, and how do you manage that as they grow? And it kind of culminated for me as a general manager. My previous company was acquired by AWS, and so I found myself, within the hyperscaler world, as opposed to competing with or partnering with or whatever. I was actually inside running
Right.
very, very large hybrid cloud storage services. And
Wow.
so the experiences that I had there were the ones that are pretty formative for me for wanting to start Causely, which is what it feels like to be the owner of the service, as the Amazon model is, very much focused on service owners and small teams, and like really like you build it, you run it, you own it, all that kind of stuff. So doing that at global scale and having things break all the time, constantly, and it wasn't even just necessarily your services. Like you made some changes, something happened, but then like 3 other services had other things going on and they impacted you, and you were dealing with the impact of it. And so on call, being paged, trying to pull people together from different teams with different expertise. If the right person wasn't available, you could get yourself into a difficult place to to get to the root cause. So I like to say, like, I lived that, so I know how that
Nice.
feels. And then the
Right.
people who are the founding team, Shmuel and the founding engineering team that have built this core the Causal AI core platform, and also the products that we're building around it. Like they have what I would say is like unfair advantage in understanding how you build this stuff and how you do it leveraging causality. So,
Hmm.
so it's exciting and it's very cool. And we're doing it as a remote company. So that's new too. We're like, we're remote from birth, and doing
Smart.
it around
I think
across the
it's
US and whole internationally and stuff like that. So
I think it's I
let's
think
just
it's
say it's never
brilliant.
dull. Never
Yeah,
dull.
no. Well, and you speak to being inside AWS, and of course have owning the product, owning the service. So when something goes wrong, it's up to you to figure that stuff out. And I see this time and time again in the enterprise software world where someone experienced a very hectic situation or a very challenging problem in a past life, and they go, "Aha, I know how to solve this." And oftentimes they try to solve it within the organization. They maybe make the pitch to the executives. They say, "Hey, we want to do X, Y, Z." Sometimes it happens, a lot of times it doesn't, and so what do? They splinter off and start something new, And I know for sure in the software world, the kernel is so important to understanding what you want to build and building a foundation like the kernel, which you've done here with these structured causal models is very important. Well, I'm a big fan of cliches. One of my favorite cliches is well begun is half done, right? If you get off on a good start, you're halfway there. But if you don't, you could be spinning your wheels for months, weeks, years. It happens. I mean, I'm sure you've seen projects at big corporations where, they launch it, they have all these great plans, and it just goes sideways. They never get there. Millions of dollars wasted. That's painful, painful to
Yes,
see and not good for morale. So what I like the most about your approach here at Causely.io, if you want to look it up online, folks, is that you've focused on causality as the core of the problem because that is what gets you to your answers. If you know the cause and you can see the effects, because that's what we're talking about, right? You see the effects, you have a model that can then understand, oh, though that array of effects means X, and that X is the cause, right?
definitely. Yeah, and a lot of it is uh, helping customers see the difference between when you know the causal relationships and when you
Right,
don't, right? Like
right,
that's a key thing. And so intellectually, people understand that this is something that is different or it's hard or it's new and all that kind of thing. But to a large extent, what they're sort of saying is, well, I built a lot of stuff and I have a lot of tools and I collect all this data and I have all these people that I've trained and I have these run books and like it's layers and layers of technology and process, that people have had to put. You can't run large scale applications without that today. It's just
right.
impossible. You would have to have a lot of things in place. And so what we're essentially trying to do is sort of break the paradigm and say, okay, that's the way you do it now. And I mean, it works to the extent that you keep things running, but it brings these things into such a physical, manual, like human place on a daily basis. And what if the answer was that these things were just happening automatically and you didn't have to
Hmm.
think about them anymore? And how
Yeah,
would that feel? And that's it's a very stark comparison. So
yeah.
that's our job, right? Is to make that really visible and clear.
Well, and it gets you on the path to productivity, right? Because the kinds of things you're solving for are nuisances. Quite frankly, they are not on the critical success path of designing something new. They are hurdles that you encounter along the way, hurdles that result from someone else's code. Sometimes it's from your own code. Sometimes it's just the environment. But basically, when you're fixing things, you're not building something new. You're just trying to put out fires all day and back to morale. That's not good for morale. It's not good for anyone. But I do understand and appreciate the mindset change that needs to be embraced. And, I've heard lots of different ways to describe this, but, in terms of following an algorithm and just believing what it tells you, we do that all day with our smartphones and the maps. You're just
Right.
following along with what it tells you to do. And I've learned
It's a
that there are
trust
times
building experience,
it,
right? Like the
it
first time you're
is,
like, wait, where am I going? Right. And then
right.
you're like, yeah, of course, right.
Right, although I will say that I've learned with these maps, they have difficulty in very short spaces, like, if you have to get around somewhere, they're not
Hmm.
able to yet figure out, "Hey, just pull in a parking lot and turn around." Like
That
like
is
I've
tricky.
done this several times, like, "Okay, no, it wants me to go up on the highway and around like this. No, I'm just gonna turn around and go back." So you'd have to kinda watch out for it. That's this bit of an off-kilter analogy, but point being, we're following what they tell us. We're listening to the bots as we walk down the street. Okay, turn this, turn left, turn right. So you're solving for that at a foundational level for the cause of these things. And these causes, man, the other way of doing things, the traditional correlation way, it can get done. It does get done all the time, but it takes so much time and so much effort and so much lost time in production, right? So, well, folks, we got podcast bonus segment is coming up here next. Send me an email if you want to be on the show, info@insideanalysis.com. We've been talking to Ellen Rubin of Causely, causely.io. We'll be right back for the podcast bonus. All right, folks, time for the podcast bonus segment here on a fantastic show, Solving the Observability Conundrum, Cause and Effect. We're talking to Ellen Rubin of Causely. It's causely.io on your internet browser if you want to learn more. And I wanted to talk to you, Ellen, about one of the coolest things I've seen happening in this industry, and that is open telemetry. This is just a couple years ago that it really took off, but I love this movement. I'm a huge fan of open source software, first and foremost. Hats off to Linus Torvalds with Linux. But now there's a whole stack. I mean, you and I have lived through this. The Hadoop movement, the open source movement really climbed up the data stack, and this whole spirit of openness is, I think, very powerful and very good, especially for highly s- spread out teams of people working on stuff. If there's transparency, there's trust. When there's lack of transparency, lack of trust kind of creeps up. But this open telemetry stuff, I think, is fantastic because it's a standard, and and everyone is now moving towards this standard, so we can all see what everyone else is working on, and we can at least benefit from this data source. What do you think about all that?
I think it's huge. And, it doesn't take me to say that it's catching on in a big way. You can see the statistics, in terms of how much interest there is and how many people are participating, and a lot of big companies that have gotten involved with it. And in the observability world, you definitely see that the kind of the large observability vendors have now adopted it, because typically in the
Right,
past they had some sort of a more proprietary way of
right,
capturing these data and stuff like that. And it's not new, right? The APM tools have done that for a while, but they've all realized that this is the future, and that the customers are asking them to adopt this more, kind of open standard that then can become the kind of the source of a lot of that information. And so that's great. I think it's really good for customers. It's really good for the industry. And it provides that visibility that's been super hard to have, right? In terms of all of these relationships across an environment that tell you, sort of what's connected to what and why. Like there are those types of things that are just not visible from the more traditional observability tools. The thing that we've found that's been very interesting is that, in spite of all of that excitement and interest, the adoption of open telemetry has some challenges to it, right? In terms of there are changes you have to make to your application and things that you need to do that take time. And, people are, I guess what I would say is people are taking this approach again, in which they feel that then they need to apply the open telemetry, to everything. Like it's like
right,
a blanket thing that they need to do. And then they go, oh my God, that's a huge amount of work. And also, oh my God, the amount of data that's going to be generated. What are we going to do
right,
with it? Then we have to store it, and we have to figure out how to access it. And, it becomes a data management problem on top of everything else.
right.
So there's often pushback in terms of how quickly, and we see this in some of the larger customers we're working with, of the adoption path. Like, we know we want to move in this direction, and we're going to pick certain applications where the benefit of doing it is very high, and we're going to start there. And then essentially we're going to like take on the challenges of making that work for these particular applications. And we're going to try to figure out how to do it in a more cost effective and optimized type of a way. But that isn't like a quick, like, press a button and everything's all set. Right. So
Right.
see that there are these other open source projects that are meant to help with that. So, eBPF is obviously something people are taking advantage of, to try to see things. People are using Otigos is a project that we're familiar with, where it kind of automates more of the open telemetry process. So there are different types of projects and tools that are out there to help make it faster and easier and less, kind of physical labor to be involved. But I guess I would say that um, one of the things that we believe is that, just as with all these other things that people have put in place, throwing tons more data at people to then try to analyze is again not the answer. It's like
Right.
the thing, and one of the things that I was reading recently in an article about open telemetry was, you should know what data you're looking for, and then you should optimize for capturing that data, so that then
Right.
you know what you're actually going to be learning and seeing, as opposed to, if I just can see everything, then what will it tell me? What will it teach me? Like,
Right.
like how many times do we need to do this before it becomes obvious? But like this much more sort of like, needle in a haystack, and looking for very particular things that will tell you the answers to the questions. It requires some more planning and thinking up front. And I
Hmm.
think that's where the answer to this lies. Because otherwise, you're sort of back in the same thing, which is, I have all this data, nobody ever even looks at it. I don't even know why I'm storing it anymore. And
Right.
that would be a shame for that to be the case. So we're
Well,
kind
and
of use it smart, use it efficiently.
right.
That's the plan.
Well, I'll tell you what, I'll close on this. I'd be curious to hear your thoughts on this curveball question. So I love the open telemetry because, again, it's transparency. We can all see what's going on, at least 80%, let's say, of what's actually happening. And then I'll choose my 20% of that, which is meaningful to my business. I would love to see open standards in the marketing world, in the digital marketing world in particular, because the numbers are off the charts. I almost put together a talk for the Data Universe conference called it was called Lies, Damn Lies, and SaaS Statistics, because they're just all over the map. I mean, like with YouTube or Instagram or these various engines, you throw a little money at it and all the numbers bounce off the page. And like, well, what did I actually just buy there? Like it's hard to get to the bottom of things and to correlate, and I've learned how to read through the data that I get from my email marketing tools just from usage patterns. So I know, okay, the clicks I see in the first 5 seconds of sending this email, probably spam filters, probably, some firewall kicking into place, but being able to make sense of the numbers is really important for marketers. And I haven't really seen much of a move around that. And it's like, well, Salesforce could do it or Marketo or any of these guys, but no one seems to do that. Do you have any thoughts on that? And what do you think about getting some more transparency into what these numbers actually mean and how they're generated?
I totally agree with you. You know, everybody who's in the IT world deals with these issues, right? About trying to tell your story and get out there, and we're all using a lot of the same platforms and stuff like that. But to me, it sounds like an idea for a new company. So off you go,
Ah,
off you
there you
go.
go. I actually know a senior executive who hinted at starting a new company, so maybe I'll lean on him to get the
Sounds
ball
good.
rolling. He knows a lot about Marketo too, because when you know better, you do better, right? And I think that's the key with what Causley is doing and what this future company I'm thinking about is doing. I just want to know what's happening. I want to know what's happening, and I want to know
You
the
want to know
impact
what's
of what I
happening and
do.
what do you need to do to fix it, and even better, you want somebody else to fix it automatically.
That
That's
would be great. That's right. Well, Ellen, thank you so much for your time. Look her up online on LinkedIn, Ellen Rubin, Causley.io. You've been listening to Inside Analysis.